Hi everyone. What if instead of always presenting brand new IoT features month after month, we come back to some very useful Octave features released some time ago, and we never covered in these sessions yet, and do a bit of explainer. So that's exactly what some of you guys asked us. So welcome to this fourth Octave developer session, dedicated to what's new in Octave, your monthly rendezvous with Octave CRWS H2 Cloud Data Orchestration IoT platform. And today, unlike the previous sessions, we're going to come back to some very useful Octave features for your IoT solution, as well as new features, of course, because Octave releases features every month. As always, this session is co-animated by eminent members of Octave development team at CRWS, and with me today, it's a pleasure to welcome Ian Morrison. Hi, Ian.
Hi, Thibault.
Ian is a senior staff manager, software engineer in Octave team, and with him, it's an honor to welcome today the head of Octave development team, Tom Luxac. Hi, Tom. Tom is a senior director, system architecture, IoT solutions at CRWS. Tom and his team are responsible for the development of all Octave features we present during these sessions, and I'm sure you will have plenty of questions for Tom and Ian today. So please use the chat at any time for your questions. As usual, we'll take them on the fly when we can, otherwise we'll keep them for the Q&A session at the end. One quick note before we start. In these sessions, we try to be as didactic as possible, but we do the assumption that you kind of know Octave and IoT solution development already. If that's not the case, no panic. I would just recommend you to check out Octave tutorial videos on CRWS YouTube channel. If you are watching this session live, just stay with us until the end. Otherwise, if you are watching this video on YouTube, you can pause the video now and go check out the tutorial video and come back later. Because as always, this session is recorded and will be added to our YouTube channel in the coming hours. All right, one more thing before we start today. I'd like to reiterate the offer I did last month for you guys watching. If anyone of you would like to join me virtually for one of the next sessions and show how you use a particular Octave features, for example, or do a bit of explainer on your own IoT use case, please let me know. You'll find my contact at the end. Now, let's see what's on the agenda for today. And the agenda for today is coming, I'm sure. Thanks. So two main topics today. First, Ian will present and demo ORP, namely Octave Resource Protocol. I'm sure a lot of you guys already use it or already saw it. Ian will detail the ORP client in C, in Python, and so on. He will cover the getting started, some use cases, and some code samples as well. After Ian will give the mic to Tom, who will cover the cloud connectors. He will present and demo Microsoft Azure Cloud Connector, as well as normal HTTPS Cloud Connector. I think that's all for the agenda for today. Very packed agenda. And with that, over to you, Ian, if you want to start.
Thank you, Thibault. Okay, so ORP here, I imagine everyone has at least seen it a little bit, but ORP is just a simple ASCII-based protocol which allows a client device to interact with Octave over a serial communication. And ORP is basically a proxy between the customer asset and the Octave-enabled device. So we have something like this. The asset talks to ORP, which talks to the data hub. And the data hub is sort of the central area of Octave. Once the asset can talk to the Data Hub, then it appears in the Octave system in much the same way as any other Octave service. So an asset can then create resources, push and get data, and receive notifications when data arrives at a resource. The full documentation is here on the Octave website. And for your interest, there's also the Data Hub open source project, which contains the Data Hub APIs. And one can see how those relate to the ORP protocol. So the clients, the documentation is intended to give enough information to write a client, but Sierra is also providing some open source clients examples. They can be used as diagnostic tools, or they could also be used as a starting point for developing your complete solution. We have one in C and one in Python, and the most recent one is the C example, which I'll be showing today. They're released under the MIT license, and they're available here at GitHub, Sierra Wireless, Octave ORP. The Python's been tested on Python 2.7, 3.6, and 3.8 on both Ubuntu and Windows. And the C client has just been built and tested on our standard Ubuntu 20.04 installations. And there's more info in the README file. Okay, so to get started, here's we're going to use one of the clients to do a few, sending and receiving data, etc. So the first thing we need to do is jump over to our device on the Octave UI and set it up. Where did my window go? There it is. So here's my device, and I see it's communicating. So we'll go to the Services tab. I'll go quickly here because I think everybody knows this. We choose which UART we're going to route ORP over. And I've already done this. I would otherwise click Save, but I don't need to. So we're ready to go. Now we'll go and start the client. Okay. Well, I've already started the client, but so we start the client by, let me just jump over here. I skipped a part. This is how you get the source. We can just clone the repository, CD into the C directory, and do a make. That's all you need to do. And then it's ready to go. So we'll start the client here. Just 1 second. Trying to make my example look realistic here. Okay, so my client is connected on USB 4, so I'll start it up. And you'll see these notification packets that start coming in. And that is because when the ORP service has just started, it sends a handshake packet to let the client know that it's just booted up and maybe the client wants to do some initialization, such as creating resources or registering for notifications, etc. So we can basically complete the handshake by just, oops, I should spell it properly. And we can see in the help what the functions are. We can create, delete, add handlers, push data, get data, reply, which is what I just did. I replied to a sync packet. And we can also set example, but this is something rarely done. Okay, so what we'd like to do now is push some data from the remote asset up to the cloud. And we can do this, or in order to do this, we need to create an input. So let's create an input. In this example, I'm going to pretend that there's some POC terminal, and we're going to push some data called purchases. So first I need to create the asset. So I'll use the functions that are available on the client, create an input of type JSON, and its name is purchases. And you can see that this is the packet that was sent. There's a little bit of a description here, and then the response comes back okay. Now if we go over to the UI, we should be able to find it under ORP. There it is. If we want to direct that data somewhere to a stream, we'll add an observation on it. And I'm just going to go the direct route here, Cloud Stream. I'll keep the default name and I'll save it. So now we should have an observation called purchases, and we can go and watch the stream. Okay. So let's push some data up there. So let's say, we're just going to use the commands that are available through the client. This is good for testing to see whether everything's making sense as you're setting things up. So I'm going to push some product code, a description, cappuccino, and served by Dave. And you can see it was accepted. There's the description of what was sent, and here's okay, it was sent. So we should be able to find that. There it is, it's here already. And you can, just to confirm, you can see that it was ORP asset purchases, cappuccino from Dave, and the product code. That was, we can push one more. And there's the next one I just sent. So the other sort of typical use is that you might want to send data the other way from the cloud down to your asset. And we can test that using the client as well. Here I'm just pretending that we have some pump that we want to control, turn it on and off with a Boolean. And so what we're going to do is create an app or a resource for that. And then we're going to register a handler so that we can get asynchronous data from the cloud. So I'll just first go and create the resource. There we go. Create it. That's okay, it's created. And then register a handler. The handler has been registered. Now it's ready to receive notifications from the cloud. So if I were in the cloud, I'm doing all this manually, but of course, you can use the REST APIs or Cloud Actions to send this data. And you can see under my ORP asset, there's now a pump on resource, and it's currently set to false because I was playing around before. But now let me just uncover that. And I'll apply. So I set it to true. And there we go. We just received a notification that a handler was called on the resource path pump on, and the data is true. And similarly, we can flip it again and apply. And there we go. The data is false. Is that, I guess that's clear?
So maybe quick question for you, Ian.
Yeah.
What type of hardware can we run ORP on?
Right. Anything that can communicate over UART, basically. So, we've done it on an Arduino. We had an earlier demo with Arduino. I'm using my Ubuntu machine at the moment. It can be any micro that you want. And, you could choose to use Python on a larger machine, or you can write some C code, hopefully starting with the examples that we're giving.
I guess as well, any IoT card with Sierra Wireless, like FX series or a Mango open source card with a UART communication between the IoT card, right? Would work as well?
That's right. And as a matter of fact, that would be selected here when you this is a device is a Mango, so it shows two UARTs, and the second UART is the IoT card, or sorry, yes, the second UART is the IoT card UART. No, I'm sorry, the second UART is USB. The first UART is the IoT card UART.
Okay.
Yeah. Okay, so this one, I'll try to go quickly through this one. It's periodic sensors. Now, Octave provides a way for the Octave service to ask for data from a remote asset in a periodic way. And this is more of a convenience, but it means that the asset can set up a very simple, or issue a very simple command rather, and then it will be queried whenever the Octave system wants data from it. So we just do this by creating a sensor, and let's just copy this here. I'm pretending I have a kiln that reports its temperature in degrees C, so I create that sensor. It's the number, this is the resource, and there's the temperature, or the units rather, and that's okay. And then in the UI, I see that I now have actually a set of resources for this temperature. I need to enable it. True. And let's set the period to 10 seconds and apply. Now what's going to happen is that every 10 seconds, Octave is going to ask the resource or the asset for a temperature reading. It's already started doing it here. Now things will keep working if I don't respond, but the queries are still coming in. So I can just start making some, I can just start responding. Every time one of these comes in, I respond, and so we'll show something here. When I push, the push command takes a timestamp, which is 0 if you just want to use the timestamp of the Octave device. So there I pushed a temperature of 550 degrees. And I can, keep doing it, etc. And that will make its way up to the UI. I should have actually created an observation to show it, but it will appear in the value. Temperature. I'll do one more just so that we have something to see. And there we are, kiln temperature. So I wanted to just introduce an upcoming, go ahead.
Yeah, just a quick question from Michael. Michael is asking, FX30 would require an IoT card to use ORP, or?
They're not necessarily. There are two models of the FX30. There's a Ethernet version and a serial port version. So if you buy the FX30S, which is the serial version, there's a DB9 RS-232 port on the back.
Okay, thanks.
Yeah, okay. Otherwise, if you have the Ethernet version, you can get an IoT card for it. I just wanted to point out this upcoming feature in release 3.2.0. Up until recently, if you were using ORP, the client could not access resources outside of the ORP namespace. And it only had write access to the ORP asset namespace. So what you had to do, if, say for example, you wanted to get the location into the asset, you would have to create an observation from the location resource that linked to a resource under ORP, and then you could query the resource under ORP. We've removed that restriction, so now you can just get data directly from other parts of the Octave resource tree. So for example, let's see. On this device, I'm just going to go directly and ask for the cellular signal value. And there, it's ready. You don't have to worry about configuring resources or anything like that. You can just read anything. And similarly, you can also push. So let's see, example, I've got a virtual resource on this device. I can push to it. The one thing you can't do, though, is you cannot create or delete resources outside of the ORP asset namespace. And that's just for safety. Otherwise, you could be deleting resources that are important to the rest of Octave. So we can just give a quick overview of the code if you like. So this is the C client. It's actually quite simple. It uses the TTY or serial device. And then Octave is an HDLC framed protocol. So we have an HDLC framing and deframing module or single file. We have then the ORP protocol encoding and decoding, which is again single file. And then there's a wrapper on that, which is an ORP client. It presents a function call API for the individual things that you might want to do, like create or push or get, etc. And then there's the command interpreter or the main, which is not terribly interesting, but it just parses the input from standard in. So the clients are based on the same components that we use to build the Octave firmware. The C code in the Octave device uses exactly the same framing and protocol files, so there should be some confidence that these are well tested. And the Python as well is used to drive our automated integration tests using PyTest. So this should be quite a bit of coverage on these modules, and hopefully that'll give some confidence that things will work smoothly. That is, oh, how did I do that? I can, I'm sorry. I can go back to the, I can show the code if you want. How are we for time, Thibaut?
You have a few minutes left if you want. That's fine.
Okay, I'll just do a quick show of the code. It's pretty straightforward. It's a small bunch of code. We have, I'll just look at the headers. We have our, working from the bottom up, we have our HDLC framing that anyone can use. And this is designed to work on streams, so the interface takes a context, so that if you have a small micro that can't handle very large frames or buffers, you can do something smaller and keep your state and keep parsing. And then on top of that, we have our protocol, which is most of everything. It has a few requirements here: Boolean, int, and standard def. And then there's the sizes are defined, a whole bunch of sizes for the packets, and then packet types. I'm just going to scroll down and we get to here. Everything for the encoder and decoder goes through this message structure. Basically, if you are encoding, then you fill in the relevant fields of this structure and pass it to the encoder. And similarly, if you're decoding, you pass a packet to the decoder and it will fill in what it can into the message structure. And that's it. There's really just two functions. It's pretty simple. And then on top of that, we have the client wrappers. These very closely represent the Data Hub API that's publicly available, except they start with ORP, and they take care of, they take the path or the basic arguments that you want to set, stick it into a message structure, and then call the encoder and call the send routines. And there is one as well to register for decoding. That's about it, really. The commands and main are not particularly interesting, and you wouldn't reuse them if you were making your own client. So that's pretty much everything that I have for today. If anyone has any questions, I'd be happy to answer.
Thanks. So I guess people willing to use these clients can just go to GitHub and clone the repo, I guess.
Yes,
that's it, and follow your instructions. Yeah. I don't see any more questions for Ian. Ian, maybe you can go back to the agenda now. So
okay.
If you have any more question for Ian or anything around this GitHub repo or anything about Octave, feel free to reach out to the team. I let you remember that you can. I mean, the whole Octave team is quite active on the forum. So CRWireless forum.crwireless.com/c/Octave. This is where we help people around Octave, and I'm sure Ian will have a great pleasure to support you on the forum.
Certainly.
All right. Thank you, Ian.
You're welcome. Thank you.
And now I will give the mic to Tom. Tom, are you still with us? So Tom will present now the cloud connectors.
Oh, here we go. You put my slide up. I should probably, there we go. I've made the presenter. That's right. I'm going to show my main screen. I assume it's my main screen. All right. So you folks hopefully can see my main screen here with this slide on it. Excellent news. So firstly, before I get too distracted with this, that was awesome, Ian. Thanks for showing that to everybody. ORP is getting super mature, and it is a great tool if you have an existing microcontroller-based application or another application that you want all the benefits for Octave, but you don't want to have to develop on the Octave module itself because you've got existing code or an application that just doesn't fit on an Octave module. It's so important, and it's really cool. This is the first I've seen the new client, and I'm very pleased with it. It's super great. So this is going to be very high level. What I'm going to talk about connecting to Northbound, right? So Ian showed us connecting southbound to closer to the physical world, where we're connecting to other microcontrollers, other applications, and connecting them into Octave. Once you use Octave to orchestrate that data and intelligently get it from the edge to the cloud, you want to terminate the data in some kind of cloud service, most likely. And so I'm going to show you a couple examples of how to do that. Please, by all means, make Thibaut earn his pay today. Ask him as many questions as possible, and feel free to interrupt me at any point. With this, Thibaut, I want to keep your screen close enough over here so that I can hopefully see you waving, right? I'm going to assume a little bit of knowledge of Azure Cloud Services. We're going to focus on Azure Cloud Services today, and I'm going to assume that you have a basic knowledge of HTTP and roughly how clouds work. So first thing we're going to show you is HTTPS to Event Hub. So if you're not familiar with Azure Event Hub, it is an ingestion service for Azure. It's been around for quite some time. It is the foundation for Iot Hub, which we'll show in the second part of the demo. It's very good for ingesting a bunch of data over several different protocols: Kafka, HTTP, AMQP. It'll ingest a bunch of data from producers, right? In this case, Octave's a data producer, and it will be consumed by follow-on processors. And what are those consumers? I'll show you a little bit of stream analytics here, so we can do some analytics on streaming data. The data could terminate in a database. It could terminate in a flat file somewhere. Azure gives you a bunch of tooling to take specific pieces of data from an Azure Event Hub namespace and drop it off into a follow-on cloud service, which supports whatever application you're designing. So without further ado, and as long as there's no more no questions on that, we'll jump into how you set this thing up, right? So hopefully we've switched over to my new screen. Yep. We'll start with an Event Hub. So I've created an Event Hub namespace here. I've gone to my Azure portal. I've created an Event Hub namespace, and I've created an Event Hub in it. And so I'll hop down here and take a look at the Event Hub. So I've created an Event Hub, and I've called it Octave HTTP Connector Demo, so we know what it is. It's on a pretty cheap tier, right? It's pretty low cost or almost no cost in some cases to get started doing this. It'll only retain my messages for a day, but it's good enough for this demo, I think, right? You'll see I'm writing data to it, and how do I want to send data to this Event Hub? Again, I said they'll accept Kafka protocol, they'll accept AMQP, and we're going to do HTTP because it's pretty simple and familiar. So Microsoft has a copious amounts of documentation for this product, and if you hop over to the send event namespace or send event documentation, you'll see that looks like what we need to do is to post some data to a service bus namespace which we just went over. So it's Octave HTTP connector demo to an Event Hub path, which is also Octave HTTP connector demo / messages. That'll generate an event in Event Hub. Pretty simple. Of course, if that was all, then people could anybody on the internet could post to it. So there's some authentication involved, right? So we have to find a way to only allow our application to write to it. And it uses something called a shared access signature. So we're going to create a shared access signature for our connector to use, and then we're going to put it in our connector. So we'll take a look at this, and you'll see again, if you use the Google machine and type generate SAS token, you will get directed to this Microsoft page, which gives you handy dandy examples in Node.js, Java, PHP, C#, PowerShell even, or Python, whatever or even Bash, right? So pretty ubiquitous on how to do that. What I've done here is I ran the Node version because it was the first one on the list, and I happen to know JavaScript a little bit. So I've created a token. I made the expiration a month. So you're going to want to make the expiration however long you want to not have to refresh the token in your connector, plus a little bit of cushion time in case you're on vacation or something, right? So you'll run this, and it'll generate a string, shared access signature, with a whole bunch of gobbledygook on it, which basically says that I was cryptographically signed using this secure token. Where do we get the SAS key? Right here, right? Where do we get that? Well, we get that from our connector demo if you go to shared access policies. So by default, if you're just playing around, it actually exists at the higher level at this Event Hub itself. So I got to go back a little further. So if I made the permission at the entire Event Hub namespace level. So if you look at the Event Hub namespace, I made a shared access policy. If you're playing around, you can use the root manage shared access key. That gives you capabilities to do a lot of stuff. Here, I really just need my Octave connector to be able to send events. Doesn't need to read events, doesn't need to manage the whole thing. It's probably a good security practice to create a separate policy for your connector. And so I made it here. And if you click on this, and I'm not going to do it here, even though I'll probably end up showing it later. If you click on this, it'll show you the actual keys over here, which you're going to use to feed into the generate SAS token function. And then we've got our authentication string ready. So now we've got a connector namespace ready. We've got a SAS token ready. And now we're going to connect our device. So what device we're going to use? I've got this FX30 here. Ian showed you how to make observations. Got a real simple observation that just sends cellular data to a cloud stream. So I've got a cloud stream here, and it's got data flowing in. Now I could use as a source for my connector a tag-based sourced, meaning that I could put a tag on this device or 10 devices, and as long as these devices all had a cell to cloud stream, we could run the connector against all of them. But in this case, we're going to start simple, crawl, walk, run, right? And we're going to just send the data from a single stream to the connector to Event Hub. So let's take a look at that connector. When you come into the create here, you're going to have a service HTTP. You're going to select that. You're going to select the source stream, or you could select the tag-based stream. So you could do a tag here and then pick anything here that's a tag, and we'll do that. But here we're going to go with this cell to cloud. I'm going to post data. You'll see here I've got URL type static because we know, based on that documentation here for send event up here, we know what our URL that we need to send data to is. If it was dynamic, like if you needed to change a query parameter, like you wanted to change the timeout to some different number based on this, or add some other parameter for your whatever API you're using, you can go to dynamic. And now you're going to take an event. Every time a new event comes in from the source, you're going to run this function, and it's going to generate whatever the URL should be, right? So your URL could be completely dynamic. The different, the query parameters are probably going to be the things that you change the most. In case you're using, an API that for every different device had a different query parameter, you could set that here. But I'm going to leave it back to static. The authentication we're going to do in a separate header. If you took a look at the send event API, there's a special format with these shared access signatures. So we're going to do a separate authentication header for that, or authorization header for that. The body, right now, I'm just sending the body as it's the event as it comes into Octave. So we're simply posting that every time it comes in. You could, again, do a string return from custom function. Maybe we'll play around and do that if we have time, and generate a specific custom event object if you so chose. Now we'll go to headers. So the headers here, we know we need content type application JSON. We've got authorization header, right, which is going to be our secret that we use the SAS token to generate. And so that SAS token will be used and filled into this value. We'll fill that into the value part. Again, dynamic, right? So if you're using a tag-based source, you may be having device-specific information in all these events. You want to make that part of the headers. You got a function. Returns a map, just like a header map here. We're not going to do dynamic headers for this one. Keeping it simple. And then a really important part, and what differentiates this from what you might be asking me, which is, hey, Tom, I know how to use Cloud Actions and post in Cloud Actions. Why don't I just do that? Well, if you do a post in Cloud Actions, we leave it up to you to define your own retry logic, right? So your service may be down and you may get a 500, you may get some error message on your service, and you're going to have to basically say, okay, well, if I don't get a 201 or whatever I expect, I want you to write this event into another stream that'll retry in a certain amount of time. And it could be a complicated thing. We give you all the tooling to build retry logic yourself to whatever you want. But if you want the common kind of retry logic that you would get out of an HTTP connector here, we'll retry if your service has a periodic 500 or a 503 or a 502. And to tell us exactly what's something that you should consider done and versus a successful post or put versus something that you consider to be a unsuccessful HTTP interaction, you can define your status codes here. So whether we've got a created here is what we expect, because we looked at the Microsoft docs and they said 201 is success and anything else is bad. So in this case, the Octave, the connector will retry any of these status codes up to a certain limit. So that's quickly how we send the data. If I want to make sure that this is going to work right, I can use our simulator. So to use our simulator, I can first grab an event I want to simulate. So because we've got a stream set here, I'll just pick a random one here, which has my an event. I'll set that as the one I want to test against, and then I'll run it. So this tells me that I will be doing a post to the connector demo service bus.windows.net. I haven't put the authorization in here because I didn't want to show that to you. And then we'll have cellular cells, all this kind of stuff, information. This is what we'll post over here, right? If you need to actually validate this, let me just go reload this so you can see what's going on here. So I've got my header, my secret headers in there now. So if you need to debug the SAS token, you can do it in the simulator. So I'll grab another one here, set it, run it, and you'll see that we've got the SAS token signature. Now I'm going to have to delete this after this demo, but probably better to show you how it works than not. So here we go. We've got this guy ready to go. We're going to save it, and I've actually already saved it, and this has been sending data for a good little bit to our event hub. So what's going to happen now? How do we verify that this is actually gotten over here and working correctly? Did you have something, Thibaut?
Yeah, quick question for you. Can you run two connectors at the same on the same source at the same time?
Yeah, no reason you couldn't do that. So absolutely, if you have the same source stream and you have multiple places you want to write it to, 100% you can do that, right? Connectors are independent like that. You can have as many connectors as you want in a company, and they can have sources that overlap very easily. So I'm going to jump into my namespace here. I'm going to click on process data. There's a cool little tool that they give you in Event Hubs to do real-time insights from events. So you can analyze your stuff using SQL-like query, which just gives you a little teaser for what the streaming analytics services on Azure do. So right now it's fetching events by default. It just does a select star into an output alias from HBK. If you're familiar with like Spark, Databricks, any of the other kind of streaming SQL type interfaces, this is very familiar for you, and this should give you an easy way to validate that the data that's getting sent to Event Hub is what you expect it to be. So you'll see here, this is just a copy of the events that got sent. If I wanted to select, let's say I just want creation date and events, or let's say lms.util. Say I just want those fields. I can then test my query, make sure that those are the things that are coming in, and you'll see that I've got creation date and lms.util. This gives you a really cool kind of, getting started low to no cost on Azure to get started with this kind of stuff and play around sending data and validating data to be integrated into a follow-on solution. So that's the quick and dirty for our HTTP connector demo. Is there any questions before I drive on?
Yes, Ian has another question for you. Are the resources available from inside the connector programming interface? And can I update a DH or VR, so data hub or virtual resource from the connector?
No, the connectors all start with data from the cloud. So you're going to do your edge processing, you're going to send it to a stream, and then in the cloud, this is all cloud at the center part of this, right? So the edge processing logic is separate, right, to define how we get to a stream. So the device resources and things like that get to the stream. Once you get into the HTTPS connector, you do have available to you some device metadata, like tags and things like that for a device are available in the context of the connector. So if we go back to the ability to have dynamic URLs, the ability to dynamically manipulate the body of the event, you can certainly get that information out of this, right? Does that answer the question? Is that the resources that you were talking about?
So Ian is asking.
Ian Marsden? First of all, because Ian Marsden, you should know this stuff.
No. It's not our Ian. It's another Ian. So he's asking as well if he will have to do an edge action or a cloud action to do that.
To do the connector, do we need to do an edge action or a cloud action? No, so you don't have to do a cloud action to do a connector. The HTTP connector is really almost like a special class of cloud action that's designed specifically to forward lots of data over HTTP, right? So as long as you've got a stream, we always start from a stream on the cloud side. So as long as you've got a stream, and in this case, I'm going to go back to my device here. That was an FX30 I used on this. So once you've done the bit of edge work to get the data into a stream, then from here, I can just target this stream of JSON and create my connector from the stream of JSON. Exactly. No, you don't have to do an edge action. You don't have to do a cloud action. You can literally just, in this case, I literally just took an existing out-of-the-box resource, observed it to the cloud, and then created the connector to forward that in mass without modification, without transformation, directly to Event Hub to be ingested. So you don't have to write any actions to do this.
Yep, which is super easy. Yep, thanks. He says, okay, great. So I think you answered the. I think that was good to precise this one.
We'll go right to the next piece right here, which is the IoT Hub Gateway. So this is a bit more complicated of a beast. And it's because we're basically mapping two models to each other. Azure IoT Hub is Event Hub, very similar to Event Hub at the underlying level, but on top of that, we've built some knowledge and idea of what a device is, right? And with varying degrees of complexity. Every device in Azure IoT Hub has telemetry. Every device in Azure IoT Hub also has desired properties and reported properties. Today, we're going to deal strictly with telemetry. And so if we have a bunch of Octave devices and we wanted to map them into Azure IoT Hub to Azure IoT Hub devices, we could actually use and purely send telemetry, by the way, that would be a limitation because it's one directional. We could just do a special HTTP connector. There'd be a lot of problems with that though. We'd have to do a lot of maintenance to maintain the list on either side properly. We could get into situations where if you delete something in Azure IoT Hub, on the Octave side, we'd start generating errors because it doesn't exist, and vice versa. The onboarding process would be complicated. So we made a really easy way to create Azure IoT Hub telemetry flows for any Octave device. And so the model requires a couple pieces of identifier information on either side. So we've got on the Octave side, we're going to create Azure IoT Hub ID. This is a set piece of metadata with a set name. You will see it in the UI when I show it to you on how to set the device ID for the Octave device. This should match what's present on the Azure IoT Hub side. How do we know what devices to target for this connector? Well, we use tags. You have to use a tag for this connector because it's really designed for a number of devices greater than one, right? It'll map many devices on the Octave side to many devices on the Azure IoT Hub side. And then we're going to select a stream. So if we know that my device is sending telemetry, in this case, I'm using the accelerometer. If we're sending telemetry to the accelerometer to CloudStream, I need to know that I'm targeting using this here. The connector is going to target these tags. It is going to target the accelerometer to CloudStream under every device with that particular tag. And then it's going to read this device one, so it knows that when it sends data to Azure IoT Hub, that it's sending data as device one when it does it. Because the connector is able to assume, because of the permissions that you give the connector is able to assume the identity of a set, whatever set of devices you so define, right? Typically, we recommend people just, if you're going to use this connector, create an IoT Hub that you want for your Octave stuff. Take the device level connector permissions for that IoT Hub and send it over to Octave so we can emulate as any device that you might set up there. It makes the whole process much simpler, right? So you do your isolation at the IoT Hub level. So that's the quick and dirty. Any questions before we drive on again?
I see no other question.
All right, so it's 2 right arrows for that one, and here we are. So I've made a IoT Hub instance in Azure. I have I've gone to the free tier. Again, if you want to try this out, the free tier is fine. The only thing is it's data limited, so I turned it off until right before this demo started. I turned the connector off. So we can save some bandwidth, but it's perfectly fine for prototyping. You can see I get about 8,000 messages a day out of this. So over here, what I've done, my order of operations is to go on this side, create an IoT device. So I'm going to go over here. I've created a device. I've called this Tom Connector Demo. Pretty simple to add a new device here. And this device will have a telemetry stream. We've got an underlying event hub that gives us all of the methods to talk to and from our devices with this IoT Hub device models and device awareness built on top of it. And so we'll go over here and say, well, how do I get that access that you asked about, Tom? And you go over here to the shared access policies, and there's a few that are out of the box. There's IoT Hub Owner, which is allows you to do everything. Wouldn't use that unless you get that out of the command line, right? In this case, the device connect is really important. So this will give us again a key. When you click on this, it'll give us a key, which will allow us our application, the Octave application, to emulate any device on the system. Right? It won't allow us to modify devices, but it'll allow us to emulate any device that you've already created over here on the IoT Hub side. So how do we connect to that device? Well, I've gone over here, I've created a connector. I've used a tag because I've got a device over here, my red. I have gone to my red that I'm using for this demo. I've made a tag, Tom IoT Hub Demo, true, right? So we all know that this is targeted for this particular connector. And the custom ID section, you click over here and edit it. I've got an Azure IoT Hub ID, which is TomConDemo, which matches the device that I created over here, TomConDemo. So the names, this is our ID that matches. If we go back to this is like my blue over here and my blue over here. We now have our Octave device tagged, keyed. We've created the device in Azure IoT Hub. Now let's go into the connector, set the stuff up in the middle, target the accelerometer to cloud, and we'll go to 10. So we'll hop back to our connector, and you'll see I've gone over here and used my IoT Hub name. So that's globally unique namespace. I've put in that shared access key for the device level. We pre-fill it out to device. We strongly encourage you to use device. If you try to get fancy and create a different lower level of SaaS token, we found with our customers operationally that just becomes a burden to manage, where it's easier to manage access at the IoT Hub level itself on the Azure side. So generate a device shared access policy. Just like, oh, an important thing, we've targeted accelerometer to cloud. So I'm sending the accelerometer data from this device to the cloud. And let me actually turn this on. So if I turn that on, it'll probably be good. And we've got that going. Now, heading over to body, just like everything else, we can run a string return from a custom function. So in this case, I'm actually pulling the accelerometer data out of the event. The original event doesn't have, has a full Octave event. I really just want to send the accelerometer information to IoT Hub as a telemetry stream. So I've done a little bit of JavaScript to pull that out. And if you hop over to headers, we don't need any headers right now. You can add dynamic headers. There's some implementations that require this functionality to modify the HTTP headers. If you have a follow-on system that depends on those headers, most people don't. So we've got this bad boy. Let's take a look on the simulator, make sure that everything's set up properly. So we'll grab an input event from the accelerometer to cloud stream. That looks good. Let's set that, and we'll run a simulation. And we'll say, great, that's exactly what I would be posting, those X, Y, and Z values. You'll see here console, I've updated it a bunch of times. See, I was setting it up originally a long time ago, and then I've updated it. If there's an error, you will see it here. So I'm going to save this. We'll see another updated thing. Oh, this is probably because I have not reloaded the page recently. So here we go. Body is string returned. Headers is there. It is enabled. Yeah, that was an issue of stale page. So if we go back to console, you'll see that it's been updated recently. So let's take a look at the connector. So how do we validate? We now know that my accelerometer to cloud stream, which is coming in here every 5 seconds or 10 seconds or so, is sending data. This is going through our connector, and it's going to go into this thing. So where's my fancy SQL thing? Well, sadly, there's no fancy SQL thing in IoT Hub for this type of stuff right now. But what they do give you is a handy dandy CLI tool. So we're gonna flip up over here and go back to my device so you can see the stream here. And if you've used the Azure CLI, you can go to the Azure CLI. You may have to install a CLI add-on. You'll see here I've just said I want to monitor events with this particular IoT Hub, all of them in our Octave developer subscription, and I click that or hit return on that, and you'll see that it's going to start listening. Oh, and there we go. We've got events coming in already. So this is a telemetry stream event heading into IoT Hub based on this content type, or based on this particular connector, and you'll see we're sending, and it'll just keep going. We're sending our accelerometer readings. If I go over here and like flip this guy up on my desk, you will see that the accelerometer values will change as I hold it sideways, and I think this is set up for every 20 seconds for an observation. You'll see how we just flipped over there. So you'll see it's very, very low latency from the time it gets to Octave to the time that it gets forwarded over to IoT Hub. And that's how you debug this stuff. If I wanted to change this payload, I could go into my connector. So I'm going to go over to my connector here. Let's say I really just care about the Z value. So I'm going to go into, let's close that so I don't have two windows doing the same thing. Let's say I really just care about the Z value. I'm going to go in here and say I want excel.z. I'm then going to simulate, always simulate, make sure that this is working properly, or make sure that your JavaScript won't throw an error, because it's a lot easier to fix now than it will be to fix later. And so set that, we'll run it. We'll see that I'm just sending 10.086. I'm going to save that. And we should, oh, look at that. We've now set the payload to a string. Our payload is a string instead of a JavaScript object. So you can see it's very, very quickly, we've given you a way to take events generated by a device to process them similarly to an HTTP connector, where we're giving you the ability to manipulate the different important fields. But it will work. It'll work across this connector, and you'll see again the event origin tells me it's the TomCon demo device. If I had TomCon demo 2, 3, 4, 5, and 6, when we monitor this, we'd see the events from all those devices flowing into the event hub or into the IoT hub, and each tagged with their own particular device information. So it's a pretty robust connection. Makes managing this concept of mirroring Octave devices into Azure IoT Hub, at least for here from a telemetry point of view, makes this very similar. There's a lot more development coming for this if you guys are interested. So definitely keep your ears to the ground on that front. So I see I've gone almost over time, Thibaut. Is there any questions from folks?
Yeah, so no question written. I just have one person who has raised his hand, but nothing in the chat or any question right now. So I would say, as the session is almost done, so please use the question box or the chat to ask your question to Tom right now. Otherwise, we will wrap up this session. We are almost okay, so no time left. Thank you, Tom. Thank you for this. If you can switch to the next slide, we're gonna wrap up this session now. As usual, feel free to ask more questions to the team. Tom as well is answering on the forum. So you had the forum link in the slide just before this one, and see you next time. So next month is going to be April 8th, same time as today. Feel free to apply for, as I said in the introduction, if you want to share with us your IoT use case, talk about your experience of Octave, please reach out to me or reach out to us on the forum. Don't forget to register for the next session. If you register directly to this session on GoToWebinar, you are now registered automatically for the next 10 sessions or so. So it's going to be way easier to connect the next time. Follow us on Twitter. We have a special developer channel, CR Developer, which is separated from the CR Wireless one. So don't forget to follow us there, and obviously subscribe on our CR Wireless YouTube channel. Thank you, guys. Thank you very much. Thank you, Tom. Hopefully, we'll have you in the next session. I mean, in another session, upcoming session. Ian, thank you very much, Ian. So our Ian, different from the one who asked questions. Obviously, Ian Morrison knows that by heart. All right, time to end this session. Thank you very much for your participation. Thank you, guys.
Thanks all.
See you next time. Bye-bye.